Durban is located on the east coast of South Africa, in the province of KwaZulu-Natal and in the municipality of eThekwini. It is the third largest city in South Africa and the busiest port in Africa. Durban is also a major center of tourism due to its warm subtropical climate and beaches. The basic form of on-site sanitation in South Africa is ventilated improved pit latrines, or VIPs. The management of fecal sludge from VIP latrines, from pit emptying to sludge treatment, is a service provided by the eThekwini municipality. After pit emptying, the fecal sludge is processed in the latrine dehydration, pasteurization, or LADEPA machine. The final product is a dried pathogen-free material. In the Pollution Research Group at the University of KwaZulu-Natal, a laboratory-scale LADEPA machine has been installed by eThekwini municipality in order to characterize the full-scale process. The ratio between the laboratory and full-scale machine is 1:10.
My name is Simon Mirara, a master's student at the University of KwaZulu-Natal, undertaking a study on the characterization and processing of fecal sludge based on the lab-scale LADEPA. During the operation of the LADEPA machine, pellets of wet fecal sludge are extruded and placed on a porous steel conveyor belt. The pellets are conveyed into the heating zone where they are exposed to infrared radiation emitted by two successive sources. The target product from the LADEPA is a dry, pasteurized pellet. Fecal sludge sampled from ventilated improved pit latrines is prepared by sieving it through a 5 mm sieve in order to remove rubbish and obtain a homogeneous material. Prior to performing experiments on the laboratory LADEPA, the operating parameters should be set up. This begins by adjusting the height of infrared source above the conveyor belt, after which the machine is powered on. The intensity of infrared radiation and the speed of the conveyor belt are then adjusted on the control panel. The removal rate of evaporated moisture, smoke, and odors is achieved by adjusting the vacuum valve to the desired suction flow rate. The height and intensity of infrared sources influence the temperature of drying. The drying zone temperature is measured using thermocouples and optical sensors. The speed of the conveyor belt sets the residence time of the pellets in the drying zone and is measured using a stopwatch. The suction air flow rate is measured by means of an anemometer in the outlet from the blower. The high-quality pellets are recovered from the discharge chute, placed in labeled containers and then stored in a cold room prior to analysis. These pellets are then subjected to moisture content, ash content, volatile matter and fixed carbon analysis in order to determine their drying characteristics. These analyses are undertaken using an oven or muffle furnace depending on the analysis undertaken. The pellet mass is determined before and after heating the furnace. To evaluate the agricultural potential of the dried pellets, chemical analyses are conducted to determine the nutrient content. Analysis of the soluble components, ammonia, nitrate, and phosphate, is undertaken using a spectrophotometer. Analysis of total phosphorus and potassium and other micronutrients is undertaken using a spectroscopy. After the digestion of the solid with strong acids at high temperature, analysis of total carbon, nitrogen, and sulfur is undertaken in the CNS analyzer. The dried pellets could be used as a fuel. Therefore, the thermophysical properties of the dried pellets are determined. These include calorific value, measured in a bomb calorimeter, and the thermoconductivity and heat capacity, measured by a TCI instrument. Ascaris was selected as an indicator of pathogen content due to their persistence in the environment. So if Ascaris eggs are destroyed, all other pathogens could be assumed to be inactivated. The concentration of Ascaris eggs are determined in a microscope by an external laboratory. The concentration of viable eggs provide an indication of the pathogenic characteristic of pellets and the pasteurization efficiency.
A laboratory-scale LADEPA has been installed in the Pollution Research Group at the University of KwaZulu-Natal. Experiments were performed to determine the drying and pasteurization efficiency of the process at different operating conditions. Tests on the processed pellets were undertaken in order to determine the nutrient content and thermal properties. The data has contributed to a better understanding and optimization of the process, and to the evaluation of the reuse of the processed pellets in agriculture or as a biofuel. Fecal sludge treatment processes are relatively new technologies. Laboratory work is essential for a better understanding of the phenomena involved in the process, and subsequently to improve the technology based on scientific facts. For this, bench-scale prototypes and experimental plans should be carefully designed to obtain reliable and relevant data.